So, we've all seen tornadoes that form from thunderstorms. But have you ever seen a tornado in a campfire? Here's one. Do you see it? Here it is in slow motion. Now, perhaps you've already seen video of a fire tornado here on YouTube. But a fire tornado isn't the same as a tornado in a campfire. A fire tornado is like a dust devil. It forms from an updraft, from the ground up. Still, it rotates, and that can give us a clue as to how tornadoes form. So back to my tornado in a campfire. What can we learn from this? What does it take to make a tornado? Here's what the National Geographic says.
Scientists don't completely understand how or when tornadoes form.
Scientists don't understand how tornadoes form because they don't have a good answer to the basic question, what starts a tornado rotating? One view is that winds aloft near a thunderstorm get stronger with altitude. That, in turn, causes shear. That shear forms a vortex with a horizontal axis. That horizontal vortex somehow gets rotated to the vertical. From my perspective, as a pilot and as an engineer, that doesn't sound right. It doesn't sound right to this expert either.
We don't have a good handle necessarily on the mechanisms that create that spin near the ground though.
So based on my observations from my campfire, here's my hypothesis about what it takes to make a tornado. You need at least 3 things to make a tornado. The first thing you need is a jet of air to form the core for a funnel. In my campfire, the core of the tornado is formed by a jet of hot gases coming out of the face of a log. The equivalent for a weather tornado would be a fast-moving downdraft caused by cold, dense air dropping out of a nearby thunderstorm. But downdrafts, by themselves, don't cause tornadoes. They don't rotate on their own, as the computer simulation and real life demonstrate. So, the second thing you need to make a tornado is a vortex, and it has to be a stable vortex. Now, there are lots of ways that vortices form in nature. Here's a video taken underwater of a funnel in a river that formed in a stable eddy downstream of an obstruction. But even if, in a like manner, wind going around a mountain could make a vortex to start a tornado, that can't be the mechanism for tornado formation in the Midwest because there aren't any mountains in the Midwest to obstruct the wind. What about the mechanism that forms a ubiquitous tornado in a bathtub? There aren't any obstructions in your tub, but a vortex forms anyway. But a tornado is made of air, not liquid water. Air is a gas. Gases don't respond to gravity like liquids do. Gravity doesn't pull gas molecules into a drain where they can collide and go sideways. So gravity won't act on air to make a vortex. So we come back to wind shear. As I showed earlier, everyone sees that wind shear must be involved in making a tornado vortex, just like wind shear causes the giant red spot on Jupiter to rotate. In my campfire, the shear starts with hot air rising on the left side of the log. On the right side, cooler air descends as it's drawn into the fire to replace the rising air. The rising and descending air create a vortex, which rotates clockwise around the log. You can see it in the slow motion video. I expect that there is a similar mechanism making a tornado. Warm and cold air rush past each other to form a vortex. The cold air is from the outflow of a parent thunderstorm to the northeast, and the warm air is updraft inflow as a child thunderstorm starts to form in the southwest. Also, you can see how well behaved or smooth the airflow around the vortex is. And that's the third thing you need to make a tornado: smooth, undisturbed airflow. Vortices, like smoke rings, are fragile. You know how easy it is to break up a funnel in your bathtub merely by making a splash. Likewise, turbulence can break up a funnel made of air. So the odds are low that a vortex will stay intact in the turbulent air around a thunderstorm. The need for smooth air also explains why tornadoes rarely form in rain or hail. Rain and hail break up smooth air. Here's what a researcher found.
His new radar reveals something else. A narrow, dry band with no rain or hail.
Well, what do you know? I might be onto something here. Well, that's the end of my little lecture, but I've appended a minute of super slow motion of the tornado in a campfire for your viewing enjoyment.